All right, so as Scott said, I'm going to talk about strategy-proofness, investment efficiency, and marginal returns. And I should point out that this is joint work with Scott, who just left the room because he knows this paper really well, and with Fahito Kojima, who's unfailingly polite. So, the design of market mechanisms has become a central focus of economics. A lot of us here have spent a lot of time and a lot of years, a lot of blood, sweat, and tears thinking about this issue. And in fact, a lot of us actually spent time, people who do stuff in the real world, not like me, have actually spent time designing auctions. So we had a very nice talk from Kevin earlier today about the FCC spectrum auctions, where he talked about one aspect of the design of that. Al Roth, of course, won the Nobel Prize for designing the labor market clearinghouse, the NRMP, among other market designs, school choice mechanisms, which we've heard about from Sam and from others, as well as course allocation mechanisms, and so on. So analysis, though, has really focused on what I'm going to call, I think, by and large, on two properties of mechanisms. The first of these is sort of very natural for economists, which is ex post efficiency. So we all get in the room, we're going to run this mechanism to allocate coffee, and we want to allocate the coffee efficiently. The people who enjoy coffee, like Michael, should get a lot more coffee than people like me who don't actually particularly like coffee. The second thing, though, that we demand of our mechanism is that we generally like it to induce truth-telling by participants. So we commonly call this property strategy-proofness. And the idea is that we don't want to make it complicated for Ramesh and Nicole and so on to submit their preferences to the mechanism. We want them to make it very easy, and the easy way is to simply have Ramesh tell me the truth about whether or not he actually likes coffee. Yes. Shocking. OK. What I want to do today, though, is I want to talk about inducing efficient investment. I want to ask a question beyond that, which is, how can we think about what people are going to do before they formally enter the mechanism? So if we think about this coffee example, maybe people need to, we also want to incentivize the coffee makers to go and produce the coffee for us. And so we want to make sure that they do things efficiently even before we decide whether or not Ramesh and Michael get coffee. So if we think about the FCC spectrum auction, even today, Verizon is making an investment in cell phone towers and marketing and so on that will allow Verizon to use any spectrum that it buys at the FCC spectrum auction. Labor markets, of course, induce ex-ante human capital accumulation. So all of you who are on the job market right now, you're basically engaging in this extremely costly acquisition of human capital. And yet, has anyone offered you a job yet? No, right? You sort of believe there's this mechanism that's going to happen 6 months from now for you, or maybe more years down the line, in which you're going to get rewarded for this human capital investment. And so we want mechanisms that are going to induce you to efficiently invest in writing good papers today. And if we think about something like Odesk, well, markets for services induce ex-ante investment in relationship-specific capital. So maybe, on Odesk, there's lots of demand for web designers. We want to induce people to go ahead and invest in learning skills that allow them to do web design. So in our paper, then, our goal is going to be to understand what kinds of mechanisms will be fully efficient. That is, mechanisms that will both choose efficient alternatives ex post, given what everyone's preferences are, as well as induce efficient investment, efficient pre-play behavior ex ante. So what is our results? Well, our big result is that we'll show that a mechanism induces efficient investment if and only if that mechanism provides marginal rewards. So in other words, the change in the payoff to an agent when his valuation of alternatives changes is equivalent to the change in social surplus. So that's what we're going to mean by this PMR, or providing marginal rewards property. So what we're going to show, though, is that an efficient mechanism will provide marginal rewards if and only if it's strategy-proof, which is kind of nice because, as I said earlier, we've actually already spent a lot of time thinking about what kinds of mechanisms are strategy-proof. So a mechanism will be fully efficient in the sense that I defined earlier if and only if it's both ex post efficient and if it's strategy-proof for the participants. And as we know from the Myers-Satterthwaite theorem, as well as lots of other work, some done by people in this room, lots of times we get impossibility results. But due to work by other people in this room, like Eric, we know lots of times that we can also get approximate. We can get these properties hold approximately, even if we can't get them to hold exactly. And so we're going to show approximation analogs of these theorems to say, well, maybe we won't get perfect efficiency. So maybe we have a mechanism that's efficient but only approximately strategy-proof. well, that'll be enough to get to induce approximately efficient investment by agents even before they come to the mechanism. We'll also show that these properties hold when agents face ex interim or ex post uncertainty. So maybe when I make an investment that's going to determine my type, how good a job market paper I write, I won't know I won't be able to choose exactly the quality of the job market paper that I write. I'm not going to be able to choose the quality of job market paper that exactly gets me a job at Booth. Instead, I'm going to make some investment, and then there's going to be some stochastic variation in the quality of my job market paper, which is then going to determine where I get hired. So we'll show that similar properties hold even when agents face this kind of uncertainty. Probably a lot of you are already thinking about Vickrey-Clark-Groves mechanisms. These are mechanisms that are known to be efficient, and they're known to be strategy-proof, and they're characterized by the fact they provide marginal rewards to each agent. So we're going to generalize this in a number of ways, but one is we're going to show that any ex post efficient mechanism which provides marginal rewards for I is strategy-proof for I. So we're going to do it agent by agent. And this is going to allow for an application to a much larger set of environments, such as matching markets and swap markets. Green and LaFont sort of show the opposite result, that all strategy-proof and ex post efficient mechanisms basically look like a VCG mechanism. And our results are going to show this equivalence holds agent by agent. Probably the most closely related paper to our work is this very nice paper and sort of undercited paper by Rogerson, which shows that efficient investment is an equilibrium of the investment gain preceding a Groves mechanism. We're going to strengthen this result by showing it's not just an equilibrium, but that you can actually say something stronger. That conditional on what other agents are doing, I'm going to make the socially efficient investment. So even if Eric, and I'm sorry for picking on you, Eric, is being a jerk and doing what's not socially efficient, I am still going to be incentivized by this strategy-proof and ex post efficient mechanism to do what's efficient conditional on what Eric is doing. Moreover, it's also going to be agent by agent. So if I imagine that a mechanism is strategy-proof for me but not for Eric, well, maybe I'm the only one who needs to make pre-play, an investment before we come to the mechanism. So it's OK that the mechanism isn't strategy-proof for Eric because I'm the only one who needs to make an investment. We're also going to show the converse, that if I want to use a mechanism that's ex post efficient, then I'm basically stuck looking at strategy-proof mechanisms if I want to get this nice property of inducing efficient pre-play investment. And finally, our approximation results are going to allow for much broader application to things like competitive markets and the upcoming FCC incentives auctions and so on. So there's going to exist a finite set of agents I, finite set of alternatives omega, and each agent I is going to have a valuation function which for now is fixed, which takes an alternative to my utility payoff, which is going to be an R. And the space of possible valuations I'm simply going to note by V capital I, or capital VI. The utility then is going to be quasi-linear and a numeraire. So my utility is going to be my valuation for whatever alternative is chosen minus the transfer that is paid by me to the mechanism. So if we're thinking about this as a second price auction, I either get the item or I don't, and then I might have to pay some transfer to the auctioneer. So an allocation rule mu is a map from after Michael and Ramesh and Nicole report their valuations that maps to the space of alternatives. So now we choose to give Michael the coffee. A transfer rule is a map from the space of valuations to the space of transfer vectors. So Michael has to pay $3 for his coffee, and Nicole doesn't have to pay anything because she doesn't get any coffee. Rough life. A mechanism then is simply going to put together an allocation rule and a transfer rule. And for the purposes of this talk, we're going to focus on direct revelation mechanisms. So the welfare of an alternative, omega, is going to be the sum of the agent's valuations for the alternative. So what we're going to care about is how much social surplus is created by choosing a particular alternative, omega. So each agent now, I, is going to make an investment decision which determines his valuation over alternatives. And it's going to be easier if we model the choice of investment as an explicit choice of the valuation function, where the cost of investment is then determined by a cost function which takes in the valuation that I chose and spits out a cost to achieve that valuation. So if we're thinking about on Verizon and I want to make the spectrum really, really valuable to me, that means I need to build a lot of cell towers so I can efficiently use that spectrum. So to make the spectrum really valuable is going to be costly. If I don't build any cell towers which can use the new spectrum, then it's not very useful to me, but it won't cost me very much either. So ex ante utility then is going to be the utility I get ex post, given my valuation, minus whatever the cost for me to generate that particular valuation was. OK, so those are the sort of basic building blocks of the model. Now I want to show you this equivalence result, which means I need to find those three properties for you. So the first is that a mechanism M is strategy proof. This is standard if the utility from telling the truth, VI, is greater than the utility that I could get from any possible lie, V bar I. A mechanism will provide marginal rewards to I if for all valuations and all possible other valuations by guy I, that the difference in social welfare that's induced when guy I's valuation changes from VI to V bar I is exactly the same as the difference in I's welfare that's produced when he goes, or I's utility, when he goes from VI to V bar I. And a mechanism will say induces efficient investment if holding the valuations of the other agents fixed, the set of valuations which maximizes my utility, my ex ante utility, where we take into account the fact that maybe it's really costly for Verizon to invest in cell phone towers, is exactly the same as the set of valuations which maximizes social welfare, again, given sort of ex ante social welfare, given the cost of generating this particular valuation. And then finally, a mechanism is ex post efficient if it maximizes ex post welfare. So first theorem, consider a mechanism M and an agent I and I. The following two statements are equivalent. That provides marginal rewards to I and it induces efficient investment by I. If M provides marginal rewards, then the agent obtains any additional surplus that he creates relative to other possible valuations that he may have. So this incentivizes the agent then to make the efficient surplus maximizing investment because he obtains sort of all the returns from that investment. If he changes his valuation and that changes the outcome and that creates a greater social surplus, what PMR says is that gives him that social surplus, and so that's going to incentivize him to make the possible investment. Conversely, if it doesn't provide marginal rewards, then I can construct a cost function CI that sort of exploits that and shows that you won't necessarily make the proper socially efficient investment for at least some given cost function CI. Now consider an efficient mechanism M and an agent I, and suppose that V is I guess this should be actually V super I is path connected. The following three statements are equivalent. Mechanism M is strategy proof for I, provides marginal rewards to I, and induces efficient investment by I. So this comes from our prior result. Intuitively, what's going on? Well, providing marginal rewards implies strategy proofness as that, so first of all, PMR requires that I obtain any additional welfare from the report VI. And efficiency ensures that any additional welfare from this true report is actually realized, because the mechanism has to actually provide that amount of the sort of the increase in welfare, because it's an ex post efficient mechanism. And so then that gives us that it's going to be strategy proof, that you're incentivized no matter what crazy things Eric is submitting to the mechanism, that you're going to want to tell the truth. So the requirements of the theorem are tight. So if you think about a posted price mechanism, a posted price mechanism is strategy proof, but it's not efficient. And it doesn't provide marginal rewards. And it doesn't actually, it also doesn't necessarily induce efficient pre-play investment. A first price auction we know is efficient, but it's not strategy proof. And there's a very nice paper by Razamene and Cantillon that shows it doesn't induce efficient investment, and in our context, it doesn't provide marginal rewards. And finally, if the valuation space is disconnected, it's easy to construct examples of a mechanism that's strategy proof and efficient, but doesn't provide marginal rewards. But not very intuitive, not very helpful in understanding what's going on. OK, so we're going to consider a two-stage game. In the first stage, agents are going to choose their investment. And in the second stage, they're going to play this mechanism, as Kevin suggested. And so the corollary is that a Nash equilibrium of the game induced by any efficient strategy-proof mechanism M produces an ex-ante welfare maximizing investment outcome pair. Unfortunately, this is not the only equilibria of these games. So we can't have inefficient Nash equilibria as well. Let's try and now nail down these ideas before I go to the approximation results by doing a simple example. So we're going to consider a second price auction with two agents, J and K, and one object. And outcome I is simply going to note that we give that object to guy I. And they're both going to have the same valuation. So it will be symmetric. So the cost for getting a valuation of VI is simply going to be VI squared. I guess from your perspective it looks like that. In the fully efficient outcome, one agent is going to invest and one isn't. So Eric is going to invest and make the object worth 1/2 to him, whereas Michael is not going to invest and the object is going to be worth 0 to him. So in equilibrium then, Eric invests, he gets the object 1/2 at a, well, the price is 0, but he has to pay 1/4 in terms of that investment. That investment costs him 1/4. Michael doesn't invest, he doesn't get the object, he doesn't pay anything to the mechanism. Eric's payoff is 1/4, and of course Eric's doing as well as he could possibly do. He was maximizing his utility conditional on getting the item, then he got the item, so he's doing as well as he could do. Could Michael possibly do any better? Well, to do better, Michael would have to basically invest in a valuation so that his valuation was higher than 1/2. And to do that, then he would have to pay more than 1/4, and he'd also have to pay 1/4 for the good because Eric went ahead and invested and is bidding 1/2 for the good. So there's simply no way that Michael can come up with a different valuation, which is going to give Michael a higher payoff. OK, so as I noted before, second price auctions are well known to be strategy proof and efficient. They're going to induce efficient investment as well. This is from that same paper. This is from a paper that sort of generalizes a result of Rosamona and Cantillon, who also consider first price auctions and show that first price auctions will actually induce underinvestment. Bilateral exchange. So we know from work by Roger Myerson and Mark Satterthwaite that no efficient mechanism can induce. So there's no strategy proof and efficient mechanism for the bilateral exchange problem. And what this really tells us is there's no efficient mechanism which can induce efficient ex-ante investment. So in some sense, this should tell us that the Myerson-Satterthwaite theorem is really all about the holdup problem. It's exactly the same thing as the holdup problem. And so if you're worried about worlds with holdup, that's exactly the same sort of worlds where you're worried about this bilateral exchange problem. There's another nice paper by Kramer and Riordan who basically show for any social choice problem, there exists a budget balanced mechanism such that the efficient outcome is a Bayes-Nash equilibrium. And in fact, it's strategy proof for all but one agent. So what this says is that if we have some problem, some social choice problem where we're trying to get people to invest efficiently, if we use a Kramer and Riordan mechanism, we can get all the guys but one to invest efficiently. And maybe there's one guy who we're not worried about his investment choice. We can make him this one agent, and then everyone else will actually be we can induce efficient investment. A mechanism M is strategy proof for I. We already went over this. Well, now I want to define what I mean by approximate strategy proofness. So a mechanism will be approximately strategy proof if, by telling the truth, if you give me epsilon for telling the truth, that's better than any possible lie that I could make. So the idea here is that maybe it's not going to be perfectly strategy proof, but figuring out the optimal lie might be costly. If it's even epsilon costly, it's not going to be worth my while. I'm just going to report the truth to the mechanism. A mechanism provides marginal rewards if the difference between the change in social welfare and the change in my welfare when my valuation changes from VI to V bar I is less than or equal to 0. Well, now that's simply minus epsilon is less than or equal to 0. So now there can be a small difference between what happens to my welfare and social welfare when my valuation changes. Finally, a mechanism M induces efficient investment by I if for all the optimal choices of investment, this gets close. Well, so what does this say? This says that this is socially efficient. The V hat I is socially efficient. Now we're going to say that, well, it's close to being socially efficient. So if Nicole is making what's for her the best possible ex-ante investment, then we want that to get us at least close to maximizing social efficiency. And then finally, a mechanism is going to be efficient within eta if it gets within eta of maximizing ex post social surplus. So consider a mechanism M and an agent I. The following two statements are equivalent. A mechanism M provides marginal rewards within epsilon to I, and the mechanism induces efficient investment within epsilon by I. So we can basically, if we're close on PMR, we're also close on IEI. let's see, I have 20 minutes. In the interest of time, I don't think it's useful to go over this proof. So I want to talk instead about providing marginal rewards and strategy-proofness. So suppose the mechanism M is efficient within eta and provides marginal rewards within epsilon to I. Then M is going to be strategy-proof within epsilon plus eta for I. So why is it epsilon plus eta? Well, consider a valuation for everyone V. And now let's think about Eric being a jerk and choosing this false report V bar I. So what is his change in utility? Well, it's simply this. Now, I'm just going to add and subtract the same thing, which is Eric's utility, assuming that he reported V bar I, if his utility actually was V bar I. So now this PMR tells me what this is. This is the change in Eric's utility, assuming he told the truth, when Eric's valuation goes from being V bar I to VI. Well, PMR tells me that, modulo epsilon, that has to get me the difference in social utility. And then I have this over here. What is this? Well, this is the difference in Eric's utility at the mechanism choosing under V bar, given his difference in valuations V bar and V bar I. But I can simply add everyone else's utility, assuming we do M of V bar at both V bar J and Vj, because for everyone besides Eric, Vj and V bar J are exactly the same. It's only Eric who's lying. Well, this is simply going to be equal to the difference in social welfare between V bar and V. And then with a little bit of just canceling the two similar terms, this is the difference in social welfare between what we get when Eric's valuation is actually V, and we actually do, and the mechanism thinks it's V, versus what the social welfare is when Eric reports V bar, but where our valuations are actually V. Well, that we know has to be no greater than eta, because we know the mechanism is efficient within eta. So it's got to always, when it responds to what the true preferences are, it's got to get with the eta of the true efficiency. And so the most that Eric can gain by this lie is eta plus epsilon. So that's going to tell you that the mechanism is epsilon plus eta strategy proof. All right. So now what you might be expecting me to tell you now is that if you go in the other direction, that epsilon strategy proofness and eta efficiency will give you epsilon plus eta PMR. And I'd really like to tell you that, except it's not true. And I'm not a jerk like Eric. So, sorry, Eric. So why is this not true? So consider the following mechanism. So what I'm going to do is I'm going to transfer, we're going to think of this as a bilateral exchange where J is going to possibly be transferring goods to I. It costs J 1 plus eta to produce each good. And I is going to, his valuation is basically a step function. So if his VI is 3.5, then his value for the first good is 3.5. His value for the second good is 3.5. His value for the, is 2.5. His value for the third good is 1.5, and so on. And we're going to consider a mechanism where I'm going to sort of give him his valuation, the floor of his valuation number of goods, but I'm going to only charge him 1 minus epsilon. So this mechanism is, if epsilon and eta are small enough, it will be epsilon strategy proof, because the most of a lie that I is ever going to want to make is he's going to want to say his valuation is just slightly higher than it is, so that he gets one more item and only pays 1 minus epsilon for it. And it's eta efficient, because there's going to be at most a difference of basically J has to give up 1 plus eta, at the margin I is going to get 1, and so you're going to have an inefficiency of eta. But the problem is this mechanism is actually n times epsilon plus eta PMR. So if the valuation of I goes from 0 to 10, the amount of loss is going to be like 10 epsilon plus 10 eta. OK. So I want to prove this theorem then. The equivalence class of alternatives for agent I, it's going to be useful when thinking about this to think about the number of different alternatives from the perspective of I. So if we think about a second price auction, if we're running this auction, Nicole doesn't actually care whether I give the coffee to Michael or to Ramesh. Nicole only cares whether or not Nicole gets the coffee. And so from Nicole's perspective, the outcome, the set of alternatives for the mechanism is really only two. Nicole gets the coffee, Nicole doesn't get the coffee. So even though that we might be, auctioning off this cup of coffee among 10 of you, really the number of equivalence classes for any one of you is just going to be two. You either get the coffee or you don't get the coffee. The theorem then is, suppose the mechanism is strategy proof within epsilon for I, and that the mechanism is efficient within eta, and that VI is path connected, then M will provide marginal rewards to I and induce efficient investment within the number of equivalence classes that I has times epsilon plus eta. So we still get that mechanisms that are approximately strategy proof and approximately efficient will still induce approximately efficient investment as long as there's not too many alternatives from the perspective of that agent. Let's see, I have 10 minutes. So let me quickly go through the proof. So we're going to, again, like before, we're going to fix the valuations of everyone else, and we're going to choose two valuations, VI and V twiddle I for guy I. And we're going to assume that it's path connected, so we're going to have a path now that we're going to be able to draw through valuation space, which will get us from VI to V twiddle, or from VI to V twiddle I. I'm going to fix some delta greater than 0, and then I'm going to define a bunch of things on the board. So I could define these with math, but no one would remember what any of them were. So we're going to start at P of 0. And we're going to go all along here, and at P of 1, we're going to be at V twiddle. Actually, I think we're going to be V twiddle. And what I'm going to be interested in, though, is these V hat super I. So what is T of omega n? Well, T of omega n is going to be the sup along the path of what's the highest possible point such that I get the equivalence class omega n. So I don't actually know what happens, because it's a sup, I don't know what happens at P of T omega n. But I do know that very close by there's going to be some V hat omega n, which is going to, for sure get me omega n. And this is going to be delta away, so very close by. And then over here, I'm going to choose just some random point, which is going to be V check omega n plus 1. So whatever equivalence class is chosen by this point is going to give me some new alternative omega n plus 1. And what's key about that alternative is it's not omega n, and it's not omega n minus 1, and it's not omega n minus 2. And I know that because the sup for omega n was here, and the sup for omega n minus 1 was here, and so on and so forth. OK, so now we know what all the notation means. So how am I going to prove this thing? OK, so let's start at thinking about, well, let's say we're starting at V check omega 1, which is here. And we know that if I say V hat omega 1, well, that's at most can get me epsilon, because the mechanism is epsilon strategy proof. So my next step, what I want to do is I want to understand what happens when my valuation actually changes to V hat omega 1. And that, well, now I've got this new term, but fine, I just added and subtracted the same thing. Now, since the mechanism is epsilon strategy proof, I can change my report and say it's actually V hat omega 2. So what happens? Well, I get at most an additional epsilon, right? Because again, the mechanism is epsilon strategy proof. Moreover, I know that the difference between V hat omega 2 and V hat omega 1, so think of being here, is at most 2 delta. So if I switch my preferences to V check omega 2, well, the most that I could have gained or lost was 2 delta, because my preferences just didn't change by that much. So now I can do the same thing. I can pull out this check V omega 2, and I can put it in the sum and move to V hat omega 2. And then I can start doing the same thing again by going to omega 3 and iterate till we get the following expression, which is my utility at V hat omega n, i.e. over here, minus some term that I'm going to have to think about, minus my utility when I started over here, is all going to be less than or equal to n epsilon times 2n minus 1 times delta. OK. Going in the reverse direction, I can use efficiency to get the following expression about social welfare. And recall, though, that my valuation under that v hat omega n and v check omega n actually give me the same outcome. They give me the same omega n outcome. Right, so that means I can change these checks to hats, and that means that I can add these expressions together and cancel this middle term. So we combine the two expressions, and we get the following. Take delta to 0, and we get our theorem. Delta 0, we have the order of omega I times epsilon plus eta is greater than the difference between going from v check omega 1 to v hat omega n. So I have 5 minutes. So I want to talk a little bit about information and uncertainty. We're going to allow for two types of uncertainty here. So one of which is that's uncertainty which is resolved after investment but before mechanism participation. So think of this as the uncertainty from writing your job market paper. And the second is, not knowing exactly what quality that job market paper is going to be. And the second is uncertainty which is resolved after mechanism participation. So maybe what the department really is interested in is how good of an economist you are, but we're not really going to know that until 6 or probably more years later. We're just going to know the quality of your job market paper. So the set of distributions over valuations is going to be denoted by curly VI, and the set of distributions over distributions of valuations is going to be blackboard bold VI. And all of the definitions sort of extend to this more general environment. And the approximate ones do as well. I don't think it's useful to restate them here, particularly in the last 6 or 7 minutes. So instead of that, I want to give you an example of how we think about information acquisition. So consider a simple second price auction. We're going to have one item and two bidders, I and J. And again, the outcome K will denote that K gets the item. And the valuation space for bidder I is going to be either 10 or 20. So he either values the good at 10 or he values the good at 20. And he doesn't, and if the other guy gets it, he gets a value of 0. And I want to consider 3 distributions over valuations. So the first of these basically says that the item for sure is worth 10 to me. The second one says the item for sure is worth 20 to me. And the third one says, I don't know. Half the time it's worth 10 to me and half the time it's worth 20 to me. So now I want to concentrate on 2 distributions over distributions of valuations. So VI is the one where half the time it's worth 10 to me for sure, and half the time it's worth 20 to me for sure. And the other one is where it's worth 10 to me half the time and 20 to me half the time. The difference between these is that I find out whether or not the object is worth 10 or 20 before I go to the mechanism. So under VI, I find out before I go to the mechanism. Under XI, I don't. The item, there's still uncertainty. So you can think of VI as acquiring information about the true value of the item to me. And we're going to fix the valuation of J. We're simply going to say the item is worth exactly 14 to him, or yeah. And he doesn't get any value from the other guy getting the item. So what's going to happen here? Well, let's assume the cost function is going to be, it's going to cost me 1 to engage in information acquisition. So if I want to go out and find what the item is truly worth to me, I have to, send some geologists out to the oil tract. They have to find out whether it's really worth 10 or 20 to me. The other guy wants to log it, so it's worth 14 to him for sure. If I don't send any geologists, it's free. So it's going to be optimal then for I to actually go ahead and investigate the oil tract. So his expected utility from investigating is, well, with probability 1/2, the item's worth 20 to him. He bids 20, the other guy bids 14. He gets it for 14, so he gets a utility of 3. He doesn't get it if it's only worth 10 to him. He spent 1 to pay for the geologists, and so he gets a total value of 2. But if he doesn't know the value of the item, he's going to bid 15. That's his expected value. He gets it for 14 for sure, so the value of the item is 1. It's also socially optimal for I to choose, this should be blackboard bold VI. Why? Well, what's the expected social welfare from choosing blackboard bold VI? Well, it's 1/2 the time the value to society that's created is 20. 1/2 the time the value that's created is 14, and society has to take into account the fact that I had to spend money to hire the geologists. So the expected utility to society is 16, but the expected social welfare from Xi is just going to be 15. So he's going to get the item for sure. He's going to get, and it's worth an expectation 15 to him. And so you'll notice that it's also optimal from a societal perspective for him to go in and make the investment. And it's not by chance the difference between 16 and 15 and 2 and 1 is both 1 in this example. OK, so to our results. Consider an efficient mechanism M and an agent I and I. And suppose that VI is path connected. The following 3 statements are equivalent. The mechanism M is strategy-proof for I. It provides marginal rewards to I, and it induces efficient investment by I, even in this more general setup. And approximate versions of these results also hold. And in particular, our results show that efficient strategy-proof mechanisms induce efficient information acquisition. So this is related to a very nice paper by Bergman and Valimaki, where they sort of show that VCG mechanisms get people to acquire information or acquire efficient signals before going to the VCG mechanism. But of course, here we can allow for not just getting signals about the true value of the item, but also making investments that help determine the true value of the item. So maybe I simultaneously send the geologists to go find out how much oil there is in the oil tract, while at the same time buying better oil drilling equipment. So what are some applications of this? Well, large competitive markets are efficient and approximately strategy-proof. There's a number of papers, one by Eric, but by others as well, who touch on this point. And if we think about what's going on, well then, or if we think about the application, well, we have ex post efficiency, we have approximate strategy-proofness. That's great. That tells us we should also get approximately efficient investment by agents before they come to the market. Cathari et al. Have a very nice paper about thinking about approximate VCG mechanism or multi-unit auctions. So they provide a computationally tractable algorithm that's approximately strategy-proof and approximately efficient. Well, it should induce approximately efficient investment as well. Tadashi Hashimoto, who I think is Michael's student, has a very nice paper on general allocation problems, providing mechanisms that are exactly strategy-proof and approximately efficient. Again, you can apply our results. And the upcoming FCC incentive auction, for reasons that Kevin Leighton Brown talked about, we don't want to use a VCG mechanism. It doesn't really work well. But it is actually the current design, at least as I understand it, is strategy-proof, but is only approximately efficient. OK, I've just about used up all my time, so I'll conclude. Inducing efficient investment is a key consideration in many settings where economists will design markets. We not only want to do things that are efficient ex post, but we also want people to invest efficiently ex ante. Ramesh wants sort of the right number of people and the right people to come to Odesk. We want the cell phone companies to invest in cell phone towers sort of efficiently. And we want, of course, we want all our grad students to invest efficiently in writing good job market papers. Our work shows that ex post efficient and strategy-proof mechanisms do in fact induce efficient ex ante investment by mechanism participants, and results for approximate versions of these properties hold as well. So we can think about spectrum auctions, labor markets. So maybe we do actually get our grad students like Nick to write efficiently, to invest efficiently in writing good papers. And if we think about markets with relationship-specific capital, as long as they're thick enough, we should also see efficient investment in those settings. And that's it. Eric?
I have a question. So another way to interpret, or an additional way to interpret your results is as another argument for using a strategy-proof mechanism as opposed to a non-strategy-proof mechanism. I'm trying to understand though, where did you use the fact that the mechanism is dominant strategy? Is that compatible with is that compatible in the results? So
you mean intuitively or mathematically?
Where's the strategy-proofness per se matter as opposed to, so obviously we use a mechanism for flawed incentives where.
So I think the reason the strategy proofness matters is that if I'm thinking about changing, when you think about going back to investment, I have a lot more opportunity, I have the ability not just to actually misreport my type, but to completely change my type. And so that gives me sort of more play, and that's why I need strategy proofness instead of some kind of Bayesian Nash notion.
So the kinds of things that wouldn't, so James, you can give an example, a kind of simple example where the mechanism is efficient, Bayesian Nash incentive compatible,
strategy compatible, yeah.
And there's something in the.
Right, so actually no, that would be a good example to make, I think. So to find a mechanism that's Bayes Nash efficient, but it doesn't have this.
Probably this relates to Michael's question about first price auctions earlier. Where first, there's something, these investment games also just create symmetries which make stuff in the S tier analog.
Right.
So a lot of the work in ante papers, asymmetric first price auction.
They're ugly, yeah.
Traction, they do some stuff in the paper, so is the strategy proofness just to get? You're just trying to understand exactly where the strategy proofness per se comes now. In addition to strategy proof mechanisms in tractable and elegant ways.
Right.
Proofs that are simpler to see mechanically.
Yeah. So I mean, I think it has to do with the fact that. Yeah. I mean, Scott, do you want to?
We're passing through a green wall like there are analogs of green wall for patients that have like this or something like that. So I think there's, but you change your timing stages of things relative to timing. So you're making analog type theorem for example of compatibility. I think an additional complexity here is that it's already sort of very complicated to think about an individual's investment changing the moving allocation at the individual level. Once you move to something like more like a group strategy group type condition where you have the ability to influence others, I would also worry that you can sort of get further subordination to the individual may move their type to try and skew everyone else's types or something like that. So again, they're
Maybe skew their reports.
Sorry, skew the reports, which then skews the types.
So this kind of relates to my earlier question that there being, you have dominant strategy inside the compatibility at the second stage. We actually don't need that in the first stage. The first stage is more of an national stuff. And in the investment stage.
Yes,
so
yeah.
I'm just trying to understand exactly where you're using the dominant strategyness, where you're just using.
So I think we need the dominant strategyness in the second stage to think about all the possible deviations, sort of catch all the possible deviations in the first stage. Whereas just Nash is not enough, because in some sense I have more ways of deviating in the first stage than I have in the second stage.
Just related to that. Okay. So there's a footnote in your slides that's my idea that is not actions. How actions or how those and you provide any conditions.
It's very hard to recognize. Basically, it's about miscoordination. So think of the two. the second price two-person auction example that I gave you, you can imagine that in that case, Michael was slightly more efficient in investing. But once Eric has gone ahead and invested, it's still going to be optimal for Mike to not invest. So you would worry about these kind of miscoordination equilibria. If you could somehow send a public signal to people saying this is sort of the equilibria that you should play, then you would expect people to play the right equilibrium.
So as much as I hate to sign this discussion in my own paper, I can cut us off. Let's thank John and Hatfield.